Alright gang, so what we got is a walk-in freezer. So when we got here, the compressor was not running, condenser fan was not running. Checked the power, pulled the plug. I jumped out the pressure control on low side, popped on for a second. So then when I started looking around, I found some oil down here, and then closer inspection, this wire was hitting that copper on this loop. I don't know if you can see it, but there is a rub through, or I should say a ground burn through this wire that hit the copper. So this was spraying out refrigerant. Before I got here, it was completely empty, the unit. So what I'm going to do, because it's on the bend, I'm going to clean this up. I mean, usually we would just cut it and expand it and then put a new piece in, but this is so little that I could probably sand it and then drop silver right on top of it. You got to be careful with that, because when you do that, if the hole's big enough, it'll drop silver inside the 3/8 liquid line, and then, you know, of course, you put a dead plug in it. So I'm going to give that a try, but this is just going to be a wire that burned on the copper wire and put a hole in the system. And then we'll run it through. We're going to have to pull a vacuum, everything like that. Alright, so the other complaint, I was just talking to the manager here, and she was telling me that this unit inside becomes an iceberg, so there's a ton of water on the floor. So when I'm looking at the pan, this is actually a pretty brand new pan, stainless steel. So when I got closer, I don't know if you can see that, but basically the condensate line is off. So all that water was dumping, freezing, and creating piles of ice down on the bottom. So we're going to take care of that too. That is a medium, no, it's a low temp. It's a EFSE half ZP. I believe that Z is low temp. Time clock feels nice and loose. Just clicked out, so get this brazed up, cleaned up, and then move on. Move these wires out of the way for when we brace, and then I gotta remember, you gotta wire the repair. Right here I can see the copper through the casing, so it's gonna have to be cut, reconnect, put a connector on there so it doesn't happen again. move these wires out of the way for when we brace. And then I gotta remember, you gotta wire the repair. Right here, I can see the copper through the casing, so it's gonna have to be cut, reconnect, put a connector on there, so it doesn't happen again. Make sure you get this nice and clean. Alright, gang. So what I'm going to do, I'm going to drop silver on, but there's a little trick to it. When you drop it in like this, you can't let it get too liquidy, because what'll happen, it'll drop inside the copper tubing, and then put a dead plug into your TXV valve. So what you do is you get it hot, pull the flame away.
Sir?
Oops, sorry, want me to move?
Oh, no, you're fine.
Okay.
Thank you.
Sorry. So what I'm going to do is when this gets hot, I'll pull the flame away, and I want this silver going nice and thick so it doesn't go into the copper. And then we should be good. But if it was on a straight piece, I would have cut it out, but it's on a loop, and I would have to make up a whole new loop for this to work, for the traffic. So we'll go from there and see how it goes. See how I'm pulling away? Now I'm going to coat it. Now I know it didn't drop in there. And there goes the coating. So I want them pretty thick. I know that it didn't drop inside the pipe because it went on nice and thick. And no, I do not use any flux. I got 15% silver and it flows very good. You don't need no flux. I'll do a wet rag wipe on that and it'll look nice.
All right?
Alright gang, we're gonna grab the vacuum pump, gonna pull a vacuum on this, check for leaks. Your workout here, all this climbing. I'm going to pull it down to a vacuum, time it out like we do on the other videos. Make sure we don't have a leak. Then we'll fill the system. Alright, so it's been about a half hour. We're at 2983. I'm going to shut it down here and then we're going to time it out. Alright, we're all set. We'll let that sit a half hour, make sure we don't have no rise or drop. Then we'll open it up. Alright, so we have 19 minutes on the clock. Still at 2983. No rise, so this system's going to be tight. We'll give it another 10 minutes, but I can tell you now it's going to be pretty tight. And then what I did is I put a connector here, and then what we're going to do, I'm going to put wire ties on these wires so that they're nice and tight to one another, so they go through the loop without touching the copper, and then I'll wire tie inside to the other wires to pull it tight. So we don't want the same thing to happen again. So that'll work out pretty good. So crimp that connector on, so we're good with that. Alright gang, so what I'm going to do, just to test this new pan, we put a new condensate drain on. Dumping water down. You say we're dumping water out into the pan, so we're good, nothing's leaking. So we took care of that issue as well as the rub through, or you want to call it a burn through, whatever you want to call it. The electrical line hit the copper and burned a hole through it. So we silver brazed right over top of it, being careful not to drop any silver in a 3/8 to discharge. So, and now we are 32 minutes and we're still holding tight, no rise. So system's calling for 80 ounces, so we're going to dump 5 pounds into the system, 404A. Got a K-body compressor here. KVG, looks like it's a 2010. So got high-low pressure controls, which actually worked and saved the compressor. So knocked the system right out of line because of the low. Lights are too bright. Alright gang, so we pulled in 3 pounds, 7 ounces, got a little bit more to go. So I'm just going to let it rest for a few. And then we're going to fire this baby up. And we'll go over something. Once again, my battery's dying here. So hopefully I could video the whole length here and let you see the numbers on the gauges. So we're going to let it sit for about 5 minutes after dumping refrigerant in, and then we're going to fire it up. Alright gang, I'll fire this thing up. Remember, we only have 3 pounds, 8 ounces in. Units calling for 5 pounds exactly, which is 80 ounces, 404A. And this is a low temp cooler for the K-body. Start dumping some more refrigerant in. At least get 4.5 pounds in. Hopefully you guys can see that. So I'll get a gauge for that. I'm going to say it's about 80 degrees where my gauges are sitting. So that head pressure is not looking too bad. Fans aren't on inside. They shouldn't be. We'll check that out in a minute. It's a freezer. Till that click sign reaches 32 degrees or below. But it's running a -10 of that right now, and we're running about 23 psi, 404A. We're at 4 pounds, 1.5 ounces. Can't really see the sight glass, but few bubbles, but starting to clear up. Can't always go by the sight glass, guys, so I think on the next video I'll break out my clamps. Test though, we can put clamps and we can do superheat and subcooling. So it's a TXV on this unit, so of course we're going to have to do subcooling. And there are ways to, every now and then when you put a new TXV in, you got to adjust the superheat through the TXV. I'll show you how to do that when that time comes, I guess, when we replace the TXV. 4 pounds, 1 ounce, 1 3/4. I'm going to hold off on that until those fans come on, and then we'll see where we're at. Alright guys, so we still don't have no fans. Okay. So, I don't know if you can see that, but you can see it's starting to frost up on that evap now. Cold air is hitting my face. It's dropping down right in my face. Should be getting pretty close for that clicks on to close, and these fans will be coming on, and then we'll finish our fill of our refrigerant at that point. I don't like filling it exactly 5 pounds. I keep a couple ounces out until these fans come on. We see where we're at. Alright, so fans are on, running to -14. See our pressure drop, starting to come back up. Head pressure still holding around 103-degree liquid, 249 psi, 404A. And I now have 4 pounds, 5 ounces. We're going to hit that up right now. £4, 11 ounces. Like maintaining a 10-degree evap. Depending on how the TXV is adjusted, this one seems like it's right on the money. So we're holding a -10-degree evap right now. 23 psi on your low side. We can bring that liquid just about 110 degrees. And that's almost going to be the right amount of charge. And that's without checking subcooling. I'm going by their plate right there. This unit does have an accumulator right there. So it's able to store the liquid. Alright, we're at 4 pounds, 14 ounces. So I think we're going to leave it there. Now remember, when I shut this down, or actually I should say pull my hoses off, I want to shut my liquid side first, and then whatever's in my line I'm going to pull into the system. I'll bleed it right through, and that'll give us an exact charge. So I don't want to go any more than what I have in there right now. So we'll disconnect, bleed that liquid side over to the suction, and that'll give us a pretty good charge of 5 pounds. So that's where we're at. Nice quick fix. The only thing, I got the straps right here. I'm going to strap these up, get them nice and tight so that they don't rub through the copper again. And that's the last thing we have to do here. Watch it for a while, watch it come down to temp, and we'll move on. Thanks for watching. Talk to you later. Running at -9-degree evap. So we're looking pretty good. Actually, for the hell of it, we might blow that coil out. It's not that dirty, but every little bit helps.